Hello friends, welcome to the next lecture of Message Digest Algorithm 5, that is MD5. Now MD5 is another algorithm which is being used for finding the hash functionalities, and it is a widely used algorithm for finding the hash functionality of a message which then gives you the output of 128-bit. Basically, this particular algorithm is being implemented in many of the techniques whenever we want to implement the hashing functionalities for the encrypted message. So let's begin with MD5 algorithm. This is the outline which we'll be seeing in this particular lecture, that is what the MD5 algorithm is, what is its algorithmic structure, what are the different implementation steps, what is the performances, comparison with the MD4 algorithm, and the summary. So to begin with its introduction, MD5 algorithm was developed by Professor Ronald L. Rivest in the year 1991. And according to RFC 1321, MD5, which is a message digest algorithm, takes as input a message which is of any arbitrary length and produces a fixed output of 128-bit, which is also called as a fingerprint or the message digest of the input message. The MD5 algorithm is intended for digital signature applications where a large file must be compressed in a secured manner, which is being encrypted before its encryption process, and it is done with the help of a private, or we can even consider it as a secret key, under a public key algorithm, or under a public key crypto system. It can be any type like RSA or DES or AES or any other algorithm which is being used for the cryptographic functionality. So this is the MD5 algorithmic structure, wherein you can see that 128-bit constant is achieved, message is being padded, and this message which is being padded is the input message, and we have to pad this message to make that particular input a multiple of 512 bits, and that padded message will then be undergoing the functionality to develop the message digest. And then we have different steps to be performed in the sequential manner to get the message digest at the end, which will be then of 128-bit fixed size block. So let's begin with the implementation steps. The first implementation step in the message digest algorithm is append the padding bits. And as I just told you that these appended bits are useful for making the input message a multiplier of 512 bits. So the input message is padded, which is nothing but it is extended so that its length, that means the input message's length, should equals to 448 mod of 512. That means it should be multiple of 512. Padding is always performed even if the length of the message is already 448 mod 12. Padding is performed as follows. A single 1 bit is appended to the message and then 0 bits are appended so that length in bits of the padded message becomes congruent to the multiplier of 512 bits. At least 1 bit and at most 512 bits are appended. The figure gives you the idea of how the padding takes place. The original message is padded with the bits, and these bits can vary from a single bit to 512 bits to make it a multiplier or to make it congruent to 448 mod of 512. So the output we get is the original message plus the padded bits. Step 2 is append the length. A 64-bit representation of the length of the message is appended to the result of the output which we get from the first step. If the length of the message is greater than 2 to the power of 64, only the lower order 64 bits will be used. Here you can see in the figure that original message plus the padded message which we get from the step 1 is then appended with the length of the message, and then everything is combined, and whatever the combined output we get is then considered at the complete data which is to be hashed, the complete data which has to be undergone, which has to be undergo the digest functionality. So the input message will have a length that is the exact multiple of 16 words, and this last input, that is data to be hashed, this will be then exact multiple of 16 words, that means 32-bit each. And the step 3 is divide the input block, that means divide the output of the second step in 512-bit block, right? So whatever the message which has to undergo the digest functionality will then be divided into number of blocks, and each block will be of 512 bits. This is the third step. Now there comes the fourth step, which is then considered as a very important step, wherein we are initializing the buffers. And these buffers are nothing but a 4-word buffer which is used, that is ABCD, is used to compute the message digest. Each of ABCD is considered as a 32-bit register, and these registers are initialized to the following values which are in hexadecimal, that is considered as the low order bytes. So word A has the hexadecimal values of 01, 23, 45, 67. Word B, buffer 89, A, B, C, D. These are the fixed hexadecimal values for these 4-word buffer. The diagram also tells you. Now the fifth step is a process message in 16-word blocks. This is a very important and the final step of the MD5 algorithm. 4 functions will be defined such that each function takes an input of 3 32-bit words and produces a 32-bit word output. So each word will take the input of 32-bit words, and which will then producing a 32-bit word of output. So F, G, H, I then can consider as the different word blocks. So step 5, process blocks, which has copying of chaining variables into temporary values. It has 4 words, A, B, C, D, and then dividing the current 512 blocks into 16 sub blocks, and these 16 word blocks will then be producing the 32-bit output blocks. This is nothing but a 32-bit word output block. So functional f x y z will then xy or xz, x then g x y z is xz or y z or y not z. So in this way the function will takes place, or the functionalities will takes place, wherein the copying and chaining of variables into temporary variables will takes place. Here also we can say the shifting of the blocks also takes place, which will then be giving you the output, the final output. This is the one MD5 operation wherein you can see that A, B, C, D are the 4 blocks, or we can even say the 4 words which are then undergoing the digest functionalities, wherein we can then step 1 is there, the process, then the step 2, then addition processes are taking place, that is step 3, step 4, step 5, and at the end step 7 will then gives you the 32 bits of 4 blocks. Now how the implementation takes place. Suppose A, B, C, D, K, S, I denote the operations. So how the A, B, C, D 4 blocks. So how these operations are performed. A is equals to B plus A plus functionalities on B, C, D plus X of K plus T of I, which then shifts 3 places and then S. So for every round, we just have to perform the 16 operations. That means for every 512-bit block, we have to perform the 16 operations. So here you can see that ABCD, 4 words ABCD has been appended 071. Okay, then in the next step, how it is being done. 3 places has been shifted according to the above step. 3 places has to be shifted. So here you can see that the alphabet D is then shifted to the first position, and then the letters have been shifted. So ABCD 071 has become now the ABC 112 2. Again, then the letter C has been shifted, which makes C D A B, and again the appending of the bits. In the next step, you can see that B has again been shifted, which is making it B C D A, and again the padding of the bits. So in this way, these 16 operations has to be followed for every 512-bit block, wherein the bits of the messages, single bits of the messages will be shifting, which will then be able to produce the hash functionality for the encrypted messages. This is the performance comparison of the different algorithms, we can say, which are then used for implementations of the hash and the digital signatures. So TEA is also one of the algorithm which has the key size of 128-bit. The extrapolated speed is, that is the kilobytes per second, is 700, and kilobytes per second, the optimized speed is not given. Then the DES works upon 56 key size, the triple DES works upon 112 key size. Similarly, the RSA, SHA, and last but not the least, that is the MD5, which works on the key size of 128 bits, has the extrapolated speed of 1740 kilobytes per second, which is the maximum speed. And PRB optimized kilobytes per speed is 62,425. So this is the performance comparisons of all the different types of the block ciphers, which are then used for the implementations of the hashing functionalities, and the signatures. Now the comparison between MD5 and MD4. MD4 considered as the fourth round, or a fourth round has been added. Each step has a unique additive constant. The function g in the round 2 was changed from xy versus xz versus yz to xz versus y not z. Each step adds in the result of the previous step. Whatever the output we get after the 16 operations on 512-bit block is then added to the next 512-bit block for the performing of again the 16 operations. That means the chain is followed, the output of the previous step is then added to the next step to get the output, and this process is continuous till we implement the 16 rounds on the last bit block of the message. So the order in which the input words are accessed in rounds 2 and round 3 is then changed. The shift amounts in each round have been optimized. The shifts in different rounds are distinct. So comparing the other digest algorithms, that is MD5 is simple to implement, and it provides a fingerprint that is a message digest of the message of the arbitrary length, which will then gives you the fixed length of output. It performs very fast on 32-bit machine. MD5 is being heavily used from large corporations like Cisco Systems, IBM is there, to the individual programmers also, because it do have the greater functionalities to implement the hashes, and obviously it is much more faster than the other. MD5 is considered as one of the most efficient algorithms which are currently available in the market. Thank you guys. I just hope that you might have got the concept of the MD5 algorithm. Try to learn it, try to learn the different examples of MD5 algorithms also. Thank you.